The Paveh is a modern long-range cruise missile that represents a significant advancement in Iran's missile development program and highlights the growing role of precision-guided weapons in modern warfare. Publicly unveiled in 2023, the Paveh missile is designed as a land attack cruise missile capable of traveling extremely long distances while flying at low altitude to avoid radar detection. With an estimated range of around 1,650 kilometers, the missile provides a capability to strike targets far beyond national borders while maintaining a relatively small radar signature compared to ballistic missiles. The introduction of the Paveh reflects a broader trend in global defense technology where nations increasingly focus on cruise missiles due to their precision, flexibility, and ability to penetrate sophisticated air defense networks. Unlike ballistic missiles that follow a high-altitude arc trajectory, cruise missiles such as the Paveh travel within the atmosphere and rely on aerodynamic lift and jet propulsion, allowing them to maneuver and follow complex flight paths toward their targets. Technically, the Paveh missile belongs to the category of subsonic land attack cruise missiles powered by a small turbojet or turbofan engine. This propulsion system works differently from the rocket engines used in ballistic missiles. Instead of burning fuel rapidly to produce short bursts of thrust, the jet engine of a cruise missile draws in air, compresses it, mixes it with fuel, and ignites the mixture to generate continuous propulsion. This method allows the missile to fly for extended periods while maintaining stable speed and altitude. The Paveh is believed to cruise at speeds typical of subsonic cruise missiles, allowing it to cover long distances while conserving fuel. Because cruise missiles rely on aerodynamic lift generated by wings, the Paveh is equipped with foldable or deployable wings that extend after launch, enabling it to glide efficiently through the atmosphere during its long flight. One of the most defining characteristics of modern cruise missiles like the Paveh is their low-altitude flight capability. By flying close to the ground or sea surface, often following the contours of the terrain, the missile can reduce the chances of being detected by radar systems. This technique, known as terrain-hugging flight, takes advantage of the curvature of the Earth and natural obstacles such as mountains or hills to mask the missile from long-range radar coverage. To perform this type of flight accurately, the missile must rely on advanced navigation and terrain mapping systems that allow it to constantly adjust its altitude and course. These systems are typically integrated with onboard computers that process navigation data in real time to ensure the missile stays on its programmed route. Guidance technology is another critical component of the Paveh missile's design. Modern cruise missiles generally combine several navigation methods to achieve high levels of accuracy. These may include inertial navigation systems, satellite navigation signals, and terrain-matching guidance technologies. The inertial navigation system uses gyroscopes and accelerometers to measure the missile's motion from the moment of launch. Satellite navigation can provide periodic updates to correct the missile's position, while terrain-matching systems compare radar or digital maps of the landscape with the terrain below to maintain precise alignment with the planned route. The combination of these methods enables cruise missiles to reach targets with a high degree of accuracy, even after traveling hundreds or thousands of kilometers. From a structural standpoint, the Paveh missile is designed to balance aerodynamic efficiency with stealth. Characteristics: its body is typically long and slender, with a pointed nose and small wings that minimize drag during flight. The engine is mounted toward the rear of the missile, while the front section houses the guidance systems and payload. Engineers often use composite materials and lightweight alloys to reduce overall weight while maintaining structural strength. This balance is essential for achieving long range without requiring excessive fuel. The missile's external shape may also be optimized to reduce radar reflections, making it more difficult for air defense systems to detect or track it. Another important aspect of the Paveh missile is its launch platform flexibility. Cruise missiles are often designed to be launched from a variety of platforms, including ground-based launchers, ships, submarines, and aircraft. While details about all potential launch methods remain limited in open sources, the Paveh is believed to be primarily deployed on ground-based launch systems. These systems can consist of mobile transporter vehicles equipped with launch containers that protect the missile until it is fired. Mobility provides a significant strategic advantage because launch units can move to different locations, making them harder to locate and target before launch. Strategically, the development of the Paveh missile reflects the increasing importance of long-range precision strike capabilities in modern defense strategies. Cruise missiles provide several advantages compared with ballistic missiles, including greater maneuverability and the ability to approach targets from multiple directions. Because they fly at low altitude and can follow complex routes, they can potentially bypass certain types of radar coverage and defensive systems. As a result, many countries invest heavily in cruise missile technology as part of their broader deterrence and defense planning. The unveiling of the Paveh missile also highlights advances in engineering and manufacturing capabilities within the missile development sector. Designing a long-range cruise missile requires expertise in aerodynamics, propulsion engineering, guidance electronics, and advanced materials. The turbojet or turbofan engine must be compact yet efficient enough to sustain long flights, while the navigation system must maintain accuracy despite changes in terrain, weather conditions, and potential electronic interference. Achieving these capabilities requires sophisticated testing, simulation, and manufacturing processes. In the context of global defense technology, the Paveh missile can be compared conceptually to other long-range land attack cruise missiles developed by various countries over the past several decades. These systems have become a central component of modern military strategy because they combine long range with high precision. The ability to strike targets with minimal warning time and high accuracy has changed how military planners think about deterrence and strategic balance. Cruise missiles can be used in both conventional and strategic roles, depending on their payload and deployment strategy. For viewers of Driven Vision, understanding the Paveh missile provides valuable insight into how modern cruise missile technology works and why it has become such an important part of contemporary military capabilities. By examining its propulsion system, guidance technology, aerodynamic design, and operational role, audiences can gain a clearer understanding of the engineering principles behind long-range cruise missiles. Unlike ballistic missiles that rely on powerful rocket engines and high-altitude trajectories, cruise missiles emphasize efficiency, stealth, and precision navigation, allowing them to operate in ways that are fundamentally different from traditional missile systems. In summary, the Paveh missile represents a modern example of long-range cruise missile engineering, combining jet propulsion, low-altitude flight capability, advanced guidance systems, and extended operational range. With an estimated reach of around 1,650 kilometers, it demonstrates how advances in propulsion efficiency and navigation technology have enabled cruise missiles to become increasingly capable and versatile. As missile technology continues to evolve, systems like the Paveh illustrate the ongoing shift toward precision-guided weapons that emphasize accuracy, flexibility, and survivability in modern military operations.